NASA and the SETI Institute just finished scanning a target nobody on Earth had ever been able to point a radio telescope at before, an object from outside our solar system racing past us at 60 kilometers per second, on its way out into interstellar space forever. And for a few tense weeks in mid-2026, some of the most respected scientists in the world quietly asked themselves a question they almost never get to ask seriously. What if this thing is not talking to us, but it could be? Stay with me, because this is the real story of how humanity just checked an interstellar visitor for signs of intelligence, what the search actually found, and why the answer is far more interesting than a simple yes or no. Let's start with what this object actually is, because that context is the whole reason this search happened at all. In the summer of 2025, a survey telescope called ATLAS, built specifically to catch fast-moving objects that could threaten Earth, spotted something entirely different from what it was designed to find. Not an asteroid on a collision course, something moving on a trajectory that made no sense for anything native to our solar system, an object arriving from interstellar space, only the third confirmed visitor of its kind in recorded human history. Scientists named it 3I/Atlas. The first such visitor, Oumuamua, arrived in 2017 and was gone before we could study it properly. The second, Borisov, arrived in 2019 and behaved like a fairly ordinary comet. But 3I/Atlas turned out to be the brightest, the most chemically detailed, and by a wide margin, the strangest of the three. Its water carried deuterium levels more than 40 times higher than anything found on Earth or in any comet from our own solar system. Its carbon and nitrogen isotopic ratios pointed to formation around a star that existed in an early, metal-poor Milky Way, up to 12 billion years old, more than twice the age of our own sun. Its trajectory carried statistical oddities serious enough that even mainstream scientists felt obligated to check them carefully rather than wave them away. And that last part is exactly why the SETI Institute and Breakthrough Listen decided this object deserved a direct radio check. Not because anyone seriously expected to find aliens, but because an object this chemically alien, moving this precisely, passing this close to Jupiter's own gravitational boundary, was simply too interesting a target to leave unchecked. If there was ever a natural object worth listening to, this was it. Here is how the search actually worked. Researchers pointed the Allen Telescope Array, a network of radio dishes built specifically for this kind of work, directly at 3I/Atlas as it moved through our solar system. The instrument sifted through nearly 74 million individual signals captured during the observation window. That number alone tells you how much noise exists in the universe. Radio interference from satellites, from cell towers, from GPS systems, from literally thousands of pieces of human technology orbiting or broadcasting on Earth, all of it gets picked up constantly by sensitive radio instruments. The real work of a SETI search is not detecting signals. It is throwing away the overwhelming majority of them because they are ours, not something else's. Out of that flood of 74 million signals, automated filtering systems narrowed the field down to 201 candidates that survived the first pass. Signals strange enough, narrow enough, or positioned correctly enough to warrant a second look. 201 is still a large number, but it is a manageable one for human researchers and more refined software to actually examine individually. And this is where the process gets genuinely rigorous, because a candidate signal being real is a completely different thing from that signal being alien. It helps to understand just how much has to go right for a signal to even reach this stage of consideration. Radio astronomy on Earth is, in a very real sense, drowning in noise generated entirely by our own species. Thousands of satellites currently orbit our planet, many of them broadcasting constantly. Cell towers, television transmitters, radar systems, Wi-Fi routers, even the electronics inside the telescope's own building can leak stray signals into a sufficiently sensitive receiver. A signal search like this one has to account for all of it, cross-referencing every single candidate against known satellite positions, known transmitter frequencies, and known patterns of terrestrial interference, before a signal can even be considered a genuine open question rather than an obvious false alarm. According to the updated 2026 protocols published by the International Academy of Astronautics for exactly this kind of situation, The first question scientists ask is never whether a signal is extraterrestrial. The first question is whether the signal is real at all. Real means the event shows up in a properly recorded observation, can be traced cleanly through the entire instrument chain, and does not vanish or change character when researchers check calibration data, timestamps, software settings, telescope, pointing logs, and known operational records. A signal can pass that test completely and still have absolutely nothing to do with aliens. Only after a signal is confirmed real does the question of whether it looks engineered even come up. And engineered has its own strict checklist: narrow bandwidth, structured timing, non-random modulation, mathematical encoding, repeated pulses, and a highly localized point of origin that cannot be explained by any known natural process. So what happened to the 201 candidates from the 3I/Atlas search? Every single one of them was traced back to ordinary human interference. Satellites passing overhead, ground-based transmitters, the everyday electromagnetic noise our own civilization generates constantly without thinking about it. No transmitter above roughly 10 to 110 watts of power was detected coming from the object in any frequency range the team searched. In plain terms, 3I/Atlas is not broadcasting anything. NASA's official position and the overwhelming consensus of the scientific community remains that it is a natural interstellar comet. Extraordinary in its chemistry, but a comet all the same. If that answer feels like a letdown, hold on, because the actual scientific story here is far more interesting than a simple yes or no on aliens. And it is exactly why this search still matters enormously. This 3I/Atlas search was not an isolated stunt. It is part of a much bigger shift happening in the search for extraterrestrial intelligence right now in 2026. For decades, SETI researchers concentrated the overwhelming majority of their listening time on a narrow slice of the radio spectrum, the frequencies that seemed most likely based on human assumptions to carry an artificial signal. But a study published in mid-2026 revealed something that reframes the entire search. Researchers found that even if an alien civilization were broadcasting a perfectly narrow, engineered radio tone, the star system it was broadcasting from could scramble that signal before it ever left home. Turbulent plasma and powerful stellar storms surrounding a star can spread what starts as a sharp, narrow radio tone into a much wider, fainter smear of frequencies by the time it crosses interstellar space. The effect is especially significant around red dwarf stars, the single most common type of star in the entire Milky Way, and, not coincidentally, home to many of the most promising, potentially habitable exoplanets we currently know about. Think about the implication of that for a second. We may not be missing alien signals because they are not out there. We may be missing them because we have spent decades listening for the wrong shape of signal entirely, a clean, narrow spike, when the true signal, scrambled by the very star it left behind, might arrive looking broad, faint, and far less obviously artificial than anyone assumed. That single insight is quietly reshaping how the next generation of SETI surveys will be designed. And it means real, extraordinary alien signals might be sitting inside archived data right now, filtered out by search algorithms built around outdated assumptions about what a signal from another world should look like. Consider how enormous that possibility actually is. Red dwarf stars are not a minor footnote in this conversation. They make up the overwhelming majority, by some estimates roughly 3/4, of every star in the Milky Way. And recent exoplanet surveys have found that many of them host small, rocky worlds sitting in the right temperature range to hold liquid water. If a meaningful fraction of alien broadcasts, assuming any exist at all, are coming from planets orbiting exactly these kinds of stars, and their stars are actively scrambling those signals before they ever reach us, then the entire history of SETI research may have been listening in the wrong shape, at the wrong stars, for exactly the civilizations most likely to actually be out there. And there is more. In June of 2026, astronomers finally cracked a mystery that had genuinely puzzled the field for years. A strange class of repeating cosmic radio bursts using Australia's ASCAP radio telescope array. These are fast radio bursts, extraordinarily brief, extraordinarily powerful pulses of radio energy that flash for milliseconds and in certain rare cases repeat on a predictable pattern. For years, some of the more speculative corners of astrophysics quietly wondered whether these repeating signals could be technological in origin. ASCAP's data finally traced the source definitively to natural, if genuinely exotic, astrophysics, almost certainly linked to extreme magnetic neutron stars called magnetars, and the specific orbital or rotational dynamics that produce their repeating pattern. Another mystery solved. Another candidate for alien technology returned firmly to the natural side of the ledger. But solving it required building entirely new observational techniques that are now being turned toward other unexplained signals across the sky. This is genuinely important. This is not a story about SETI failing. This is a story about SETI getting dramatically more capable, more rigorous, and more precisely targeted with every single year that passes. Astronomers are also now able to search deep archives more efficiently than ever before. In 2026, researchers ran the observatory's first dedicated SETI survey using archived data from the ALMA telescope array in Chile, hunting through recordings never originally intended for this kind of search. No alien transmissions turned up in that pass either. But the study revealed something almost as significant as a detection would have been. A handful of routine ALMA observations, collected for entirely unrelated science, had quietly swept past millions of stars in the background of their field of view. Millions of potential targets, effectively surveyed for free simply by reanalyzing data that already existed. The search for alien technology may already be covering vastly more of the sky than anyone previously realized, while entire stretches of the radio spectrum remain almost completely untouched. This matters because modern computing has fundamentally changed what counts as a search in the first place. A decade ago, a SETI survey meant pointing a telescope at a specific star for a specific window of time, waiting and hoping. Today, an enormous amount of archived data sitting in observatory storage, collected originally for entirely different scientific purposes, can be reanalyzed after the fact using techniques and processing power that simply did not exist when it was first recorded. Every time computing power increases, every archive humanity has ever collected effectively becomes a new search, without a single additional minute of telescope time being spent. If a detail like that has you leaning in right now, hit that like button, because there is one more piece of this story that is genuinely unsettling, and it has nothing to do with searching outward. Researchers have also started asking an uncomfortable question in the opposite direction. Are we accidentally broadcasting our own location to anyone who might be listening? A study released in August of 2025 found that Earth's own deep space transmissions, particularly signals we deliberately aim at Mars and other interplanetary targets for our own missions, are powerful enough that a sufficiently sensitive receiver positioned along the right line of sight could potentially detect them from remarkable distances. We are not currently trying to hide. Every time we send a command to a Mars rover or a deep space probe, we are, in a very real sense, announcing our presence to the galaxy, whether we intend to or not. And this raises the exact question that formal SETI protocols were rewritten in 2026 specifically to prepare for. What actually happens if we do eventually confirm something real? The updated International Academy of Astronautics guidance, finalized in June of 2026, replaced decades-old first contact principles with a framework built for the actual world we live in now. A world of instant social media, leaked observatory schedules, and AI-generated misinformation that can spread faster than any verified scientific statement. The new protocols stress that a possible detection would almost certainly reach the public through many uncontrolled channels long before any institution could manage the story properly. An observatory staffer might mention something offhand. A telescope schedule might leak online. A preprint paper might appear before formal review. A social media account might exaggerate a single technical phrase into a global headline within hours. The 2026 update explicitly plans around deepfakes, automated misinformation, doxing of researchers, and the kind of round-the-clock news pressure that simply did not exist the last time these protocols were written. The new guidance insists on strict, disciplined language at every single stage. The public should always be told plainly whether an event is merely a candidate worth investigating, a verified artificial signal of unknown origin, or an actual confirmed extraterrestrial signal. And those three categories should never be blurred together, downplayed, or oversold for the sake of a more exciting headline. A raw, unverified candidate should never be described publicly using confirmed, definitive language. That distinction might sound almost bureaucratic on paper, but it exists precisely because of what happened the last time a signal like this made headlines. Back in 2020, a narrow radio signal that appeared to originate from the direction of Proxima Centauri, our nearest stellar neighbor, was leaked to the press before the internal verification process had finished. The story exploded worldwide practically overnight. Researchers spent nearly a full year afterward carefully tracing the signal's true origin, and eventually confirmed it was ordinary terrestrial interference, almost certainly leaking from ground-based equipment here on Earth. But by then, the story had already spread across the entire planet as a near-confirmed alien contact event. That single incident is a large part of why the field rewrote its own communication protocols so thoroughly for 2026, because the actual science of detecting a signal turned out to be the easier half of the problem. Communicating it honestly to billions of people in real time without the story spiraling out of control is the genuinely hard part. If you're finding this deep dive into how the search for alien signals actually works fascinating, subscribe to this channel and turn on notifications right now, because these searches are only accelerating, and I want you here for the next one. So, where does all of this actually leave us? 3. I/Atlas, the strangest interstellar visitor ever detected, was checked directly for artificial signals, and it came back completely, definitively silent. 201 candidate signals, every single one traced to human interference. No alien transmitter detected anywhere in the search. That is a real, factual, and fully documented result. But surrounding that single result is an entire field of astronomy that just went through one of its most genuinely productive years in decades. A new understanding that stellar plasma may be scrambling alien signals before they ever reach us, quietly hiding in plain sight inside a huge portion of the sky we assumed was already silent. A years-long mystery about repeating cosmic bursts finally solved through entirely new observational techniques that can now be pointed at other unexplained signals. Millions of stars accidentally surveyed for free simply by reanalyzing archived data collected for completely unrelated purposes. In a complete, sober rewrite of exactly how humanity should communicate the moment we ever do find something real, precisely because we came uncomfortably close to getting that communication badly wrong once already back in 2020. We have not found aliens. Not yet. But we just checked one of the strangest objects to ever pass through our solar system. And we did it properly, rigorously, and completely in the open, with real published research anyone can go read for themselves. And in the process, scientists discovered that the entire search itself has been quietly incomplete for decades, listening for the wrong shape of signal in only a narrow slice of the available spectrum, while millions of stars sat, unexamined in data we already had sitting in storage. Before you go, tell me in the comments below, if we do eventually detect something genuinely real, do you think humanity will handle that news calmly, or do you think it plays out exactly like the Proxima Centauri leak all over again, chaos first, verification second? And if this changed how you think about the actual search for alien life, share it with someone who still pictures SETI as a guy in a lab waiting for a single dramatic beep. It takes 10 seconds, and it is exactly how a story like this reaches the people who will find it just as fascinating as you do right now. 3I/Atlas is already gone, racing outward past Saturn's orbit at 60 kilometers per second, carrying the rest of its 12 billion-year-old secrets with it into the dark, silent on every frequency we checked. But somewhere out there, new surveys are already scanning the sky again, with better instruments, smarter filtering, and a far more complete picture of what an alien signal might actually look like by the time it reaches us. The search never stopped. It just got a whole lot smarter.